The heights of the clocks don't have to be that different though. Any difference will do. So imagine we attach two clocks to a squirrel, one on his head and one on his feet. They should tick at different rates too. The difference isn't that much. In fact, it's even smaller than it was for the building. It's only an extra 4/100ths of a femtosecond at the head for every whole second at the feet. But any difference will do, no matter how small. Unfortunately, watching clocks tick doesn't actually give us the right intuition. Let's try something a little different. If we only consider the up and down direction, that frees up the sideways direction for something else, like time, for example. This is just a space versus time graph, nothing too crazy. We've been looking at graphs like that for hundreds of years to look for patterns in motion. Except the squirrel isn't moving. Remember, we're still in that imaginary world with no force of gravity. That means we expect this squirrel to be at the same height at all times. He has no reason to fall to the ground. Or does he? Let's take everything we've learned so far and put it all together. The squirrel is hovering above the Earth in space, but is moving forward in time. I mean, everything is moving through time. But we also know time flows at different rates in different places. You could think of it like a flow gradient around the Earth. And what happens when there's a gradient? Stuff. Gradients are the reason that anything happens, ever.
All hail the gradients!
The squirrel's head moves faster through time than his feet. This gradually turns his motion arrow, what we call the fore velocity. Over time, it points more and more toward the Earth. The squirrel falls to the ground simply because time dilation exists. Surprise! We just predicted gravity. This whole time, we've been imagining a universe without a force of gravity. But as long as time passes at different rates in different places, things will fall anyway. Gravity exists even if we don't treat it as a force. Why does this squirrel fall? Because there's a flow gradient in